It's a well-known story that at the beginning of the 20th century, Albert Einstein came out with his theory of special relativity and revolutionized how we understand the world. In those early decades, light itself got the spotlight. That was when the public learned about the speed of light and its effect on space and time, and that light sometimes behaves as a wave and sometimes as matter. In a lesser-known story, in 1923, a young French physicist, Louis de Broglie, went to a party. After midnight, he began questioning the revelers. What if the physical world also has a dual nature? What if physical objects, besides their material behavior, also behave as waves? Before he would ignite a fight on the dance floor, his friends took him outside to the fresh air. Alone at last, staring at the quiet street, he knew he discovered something. And indeed, he did. When we leave an electron alone and don't try to detect its location, it acts like a wave rippling in subatomic space. Only when we observe it does it solidify into a three-dimensional solid object. But this is no news to the police. They have known this phenomenon all along. Everybody has a dual nature. Sorcerers claim that humans are bubbles of energy composed of two complementing forces. But before we delve into these forces, we must detour to a timeless debate that originated in ancient Greece, involving Plato and Aristotle. These two prominent thinkers held contrasting viewpoints on the acquisition of knowledge. Plato believed that physical objects represented temporary manifestations of eternal forms or ideas. To illustrate, he posited that every table embodies the abstract concept of tableness. Consequently, to learn about a table, we must learn about tableness. In computer science, Plato's approach finds extensive practical application in object-oriented programming languages, such as Python. Aristotle disagreed with Plato's ideals because he believed that a proper understanding of a table could only be achieved by examining the table itself and addressing the four fundamental questions associated with four causes that pertain to all objects. These causes include the material cause, what is it composed of? The formal cause, what is its shape? The efficient cause, how did it come to be? And the final cause, what is its purpose? When we answer these questions, we know everything there is to know about an object. Before Kant, European philosophers were divided between two main camps on the issue of knowledge: rationalism and empiricism. The dispute between the two was the reincarnation of the old Greek debate, adapted to the spirit of the Enlightenment. The adaptation was so thorough that they abandoned Plato and Aristotle altogether because they couldn't describe practical things the modern age wanted to understand, such as why iron rusts in the rain and how to prevent it. The young rebels needed a better theory on which they could develop their scientific method, and the atomist model, also from ancient Greece, fitted the bill. And this is how we see the world today. Everything is made of tiny particles. You know the story. Back to the rationalists, who believe that some knowledge is innate to humans and that the mind has certain inherent concepts to understand the world. Empiricists, on the other hand, think that all knowledge comes from experience. They also consider the mind only a blank slate at birth, filled with sensory data over time. Kant argued that both rationalists and empiricists are correct, but that they only tell part of the story. He claimed that knowledge comes from a combination of reason and experience. He did the unthinkable. He kept the structure of the sweet rational and filled it up with veggies from the garden. His solution to the debate was based on his theory of the mind. He argued that the mind is not a blank slate but is active in shaping our experience of the world. The mind does this by imposing its own categories of thought on the raw data of experience. The categories are the a priori concepts necessary for all knowledge. But we don't know how things are in themselves without our mind's interpretation, and we will never know, says Kant. The sorcerers agree with Kant that the world out there is not what it seems to be. In the real world, there are no objects, only the fluid emanations of an indescribable force that governs the universe. However, sorcerers reject Kant's other idea that humans cannot perceive the world without the interpretation of the mind. The whole point of learning sorcery is realizing that we can perceive energy directly without interpreting it, without turning it into solid objects. They call this experience seeing energy as it flows in the universe. Sorcerers maintain that everybody has a hidden capacity to perceive the world as energy, or perhaps as a quantum field, but is unaware of it. Let's return to de Broglie and recall why he received the Nobel Prize. Because he played with the idea that the physical world has a wave function besides being dumb matter. Sorcerers share de Broglie's view and claim that humans are not mere solid objects governed by Newton's laws. They also have a wave function ruled by laws of a different order.
When the human body is perceived as energy, it is utterly patent that it is composed of two different types of energy, two different currents of energy, two opposing and at the same time complementary forces that coexist side by side, mirroring in this fashion the dual structure of everything in the universe at large. The shamans of ancient Mexico depicted the left stream as more turbulent and aggressive, moving in undulating ripples and projecting out waves of energy. And they depicted the right stream of energy as the water inside a tank that was being slightly tilted back and forth. There were no ripples in it, but a continuous rocking motion. At a deeper level, however, it swirled in rotational circles in the form of spirals. To the eye of the seer, however, the energy of the total body is circular. This meant to the sorcerers of Don Juan's lineage that the right body was the predominant force.
In other words, over millennials, we have become hardcore materialists who have forgotten that our wave function exists. We have no idea that there are hidden resources in us, not God, not the soul, not even the neurons in the brain, but all the benefits waves can offer. Let's take an example. This is a Roman dodecahedron. Archaeologists found many in the northern part of the Roman Empire, but for some reason unknown to them, not in the southern region. It's a nice little artifact, although nobody knows what it was used for. Archaeologists can't figure it out by studying Plato's ideals because they cannot access the abstract concept of Roman dodecahedronness. So Plato's theory is of no help. They can fill out Aristotle's first three categories because they know it's made of bronze, its shape is a dodecahedron, and it was created through a casting process. But the fourth category, the final cause, is precisely what they don't know. They have no idea what it was for. So Aristotle's approach to knowledge is no help either. Modern technology can analyze its material components and tell how old they are. Still, the scientific method does not apply to discovering the reason for its existence. So we have no tools to learn about it. Therefore, the Roman dodecahedron remains an enigma. However, for sorcerers who are aware of their wave function and know how to handle it, it would be possible to focus their seeing on the object and perceive it directly as energy, without the interpretation of the mind. They could then find out what it was for and even some specifics about the life of its creator. But we don't believe in this possibility because we haven't developed the faculties of our left bodies. Thus, we disregard our wave function, our magical heritage. According to Sorcerers, what fixated humanity's perception permanently on the material aspect of reality is the same thing that fixates a child perception, the mirror of self-reflection, our inexorable obsession with ourselves. As we become more and more self-conscious, we solidify into solid, separate individuals and cease to be an integral part of the environment. You may argue that animals don't take selfies like humans, but are also solid objects. But this is debatable. We perceive them as solid, separate objects because, as Kant stated, our mind compartmentalizes energy and shapes it into the familiar world, where objects are distinct and can be classified. We have reasons to believe that some animals perceive their surroundings as energy, rather than physical objects whose visibility depends on external light sources. Who better to prove this than Albert Einstein's kitty cat? This is its story. One day, Einstein went home from a shopping trip. He liked walking around and thinking deeply about the possibilities of intergalactic travels in light of the speed of light. When he opened the main door, he discovered a mice explosion in his house. Being a contemplative man, he wasn't disturbed at all. He wrote to his old friend Schrödinger, explained the Big Bang situation, and asked if he could borrow his cat for a few weeks. "It would be a welcome respite," said Schrödinger. "I can send you the creature in a box, but I cannot guarantee you will find it alive upon arrival." Einstein did not play with dice. Instead, he played with his imagination, which was more important than knowledge. Knowledge is limited, he thought, but imagination encircles the world. He picked up the phone and dialed Alice's number in Wonderland. "Hello, Albert. What's wrong with you?" "I've been thinking about meow." "Well, yes, the Cheshire cat. Do you want it?" "Yes." "Why don't you say cheese and take a selfie instead?" "Albert, the world wants to see a grin on your face. And besides that, everybody knows you oversaturate the colors of your underwear." And she hangs up the phone. Who was that? Did I dial the wrong number and call the Queen of Hearts instead of Alice? He shrugged his shoulder and wrote another letter to another friend, who had lent him his theory of quantized energy a few years earlier, and asked if he could lend him a cat this time. No problem, said the friend. "A cat is only energy. I can quantize a cat in no time. I will send it to you ASAP." Einstein received the parcel the next day and opened it. "Oh no, what were you thinking, my friend? Subatomic particles again? This is far too minuscule to catch a mouse." But Einstein wouldn't have been Einstein if he wasn't creative. He decided to train the kitten for the job. He propped up a jar with half a walnut and waited till a mouse fell for the bait. Then he carefully relocated the captive to the hallway and removed the jar. The kitty immediately pounced on the mouse and engaged in a deadly game. The mouse darted toward the door, only to be swatted back by the cat's paw. Einstein got anxious. He thought the kitty was losing it in the semi-darkness, so he quickly turned the lights on. In the meantime, the kitten took a somersault at its leisure and shoved the mouse to the wall, giving a clear impression to Einstein that she didn't give a hoot about his light. Einstein mumbled a special, relatively common expression under his mustache and flicked the lights off. In the dark, however, he had second thoughts. So he flipped the switch back on just to test again if the light would affect the cat's behavior. But the kitten remained oblivious. Light or dark, it continued to play unaffected by Einstein's machinations. But why didn't it matter to the kitten whether the lights were on or off? Why didn't it lose sight of the mouse in the dark? We have reasons to believe that some animals perceive their surroundings as energy, not solid objects. If so, Einstein's cat, not Schrödinger's, deserves the Nobel Prize for verifying de Broglie's theory of the physical world's dual nature. The Kitten also proves the Sorcerers' claim that the lack of self-reflection revives the left body to function.